We're going to start this lesson by talking about zero and division with zero. Whenever we have zero divided by a number, like this first example, 0 divided by 6, our answer is going to be 0. Whenever we have a number divided by 0, like 6 divided by 0, that's when our answer is undefined, because we can't take 6 things and break them up into 0 groups. That's why our answer is undefined. But if we look at this other example, when we had 0 things, we could break that up into 6 groups of 0. It does still mathematically make sense. This is a concept that people tend to get mixed up, which one answers 0 and which one has an answer of undefined. So there are some memory tricks to remember this. You can treat 0 like the letter O and 6 like the number, so an N for number. And in that case, it's on, right? We can get an answer of 0. But when you have a number divided by 0, it's no, we can't do it. It's undefined. Please remember that these rules work no matter how the division is written. So if we had 0 divided by 6, that also gives us an answer of 0. Likewise, if we're thinking of it with our long division, 0 divided by 6 gives us 0. And for undefined, if we had 6 divided by 0, that would also give us an undefined answer, as would 6 divided by 0 written as long division. We'd write it as undefined. Now let's talk about signed numbers or integers. If we're trying to add two numbers with the same sign, we add their absolute values. So the absolute value, remember, is the distance from 0. So we're really just dealing with the number part. We're ignoring this sign. We add the number parts without the signs, and then we use their common sign as the sign of their sum. Remember, that's the answer to the addition problem. If we're adding two numbers with different signs, we find the larger absolute value minus the smaller absolute value, and we use the sign of the number with the larger absolute value as the sign of the sum. So if we look at a few addition problems, our first example is 5 plus -7 plus 3. So I'm first going to start, because I know I go left to right with addition and subtraction, with my 5 plus -7. They have different signs. So I need to subtract the number parts, the absolute values. So I'm really thinking, okay, what's 7 minus 5? That gives me 2. So the number part of my answer is going to be 2. Then my answer has the sign of the number with the bigger absolute value. 7 has the bigger absolute value, so my answer is going to be -2 because that 7 had a negative attached to it. I'm going to bring down that +3 and finish it for the rest of the problem. So now I need to do -2 plus 3. They also are different signs, so I need to subtract the number parts. So I do 3 minus 2, that gives me 1. So the number part of my answer is going to be 1. In this case, 3 is bigger than 2 when I just worry about the absolute values, and 3 is positive, so my answer is going to be positive. So this 1 is my final answer. If I look at the next example, I have -13 plus 14. So they have different signs. I need to subtract the absolute values, the number parts. So I'm going to do 14 minus 13, the bigger number part, minus the smaller number part. That gives me 1. 14 has the bigger absolute value, so that 1 is going to stay positive. Now I bring down that plus a -9. When I add these, I notice they have different signs again. One's positive and one's negative. So I subtract the bigger number part minus the smaller number part. The 9 minus 1 gives me positive 8. But that 9 had the bigger absolute value, and 9 had negative attached to it. So the answer to this problem is negative 8. If we think about subtracting sign numbers, we don't actually have rules for subtraction. So what we do is change it to addition. To do that, we change the subtraction sign to an addition sign. We change that next number to its opposite. So if it's positive, we change it to negative. If it's negative, we change it to positive. And then we follow those adding rules to add sign numbers. Some people remember this as keep, change, change. So if we look at this first example, I have 6 minus 10. I'm going to keep the 6 the same, change that subtraction to addition, and change that positive 10 to a negative 10. Now I have an addition problem, and I can follow the addition rules. These are different signs, so I need to subtract the number parts, the absolute values. I'll do 10 minus 6, which gives me 4. Because my 10 is the bigger absolute value, and when it's written as addition, that 10 has a negative sign attached to it, my answer is also going to be negative. If I look at this next example where I have negative 14 minus 19, I need to change it to addition first. So I keep the negative 14 the same. I change that subtraction to addition. And I change that positive 19 to negative 19. The 14 and 19 have the same sign when I look at that addition problem. They're both negative. So I need to add the number parts together because they're the same sign. When I do that, that gives me 33, and then I keep the answer, keeps that same sign, so it's also a negative answer. If I look at negative 12 minus negative 6, this is an example of when that keep, change really helps because we have double signs floating around here. So that negative 12 stays the same, that minus turns into an addition, and that negative 6 turns into a positive 6. Now that I have it written as addition, they're different signs. I have a negative 12 and a positive 6. So I subtract the absolute values to get 6. And then I look back for the bigger number part, the bigger absolute value, which was negative 12. So that means my answer is also going to be negative. If I look at multiplying and dividing sign numbers, the product or quotient, so remember product is our answer to multiplication and quotient is answer to division, of two numbers having the same sign is a positive number. But if we have the product or quotient of two numbers having different signs, our answer is a negative number. So one of the ways I help remember this is with a tic-tac-toe board. When I play tic-tac-toe, I like to win on my diagonal. So I'll put positives on the diagonal because winning's good, right? And then when I lose, the losers can take everything else. And if we fill that out, we make kind of a key for our multiplication and division. If we have, go left to right, a positive times a negative, it's going to equal a negative. A negative times a positive is going to equal a negative, but a negative times a negative gives us a positive. And if you go across the diagonal, you find that a positive times a positive gives you a positive. And we just saw the same rules that work for addition, the same rules that work for multiplication also work for division. So if we look at negative 4 times 9, I know the number parts, 4 times 9 gives me 36. And then they're different signs. One's positive, one's negative. So my answer has to be negative. If I look at -7 times -8, I know 7 times 8 gives me 56, and a negative times a negative gives me a positive. If I have -30 divided by 6, when I divide the number parts, I get 5. And a negative divided by a positive gives me a negative because they're different signs. If I have -12 divided by -4, well, I know 12 divided by 4 gives me 3, and a negative divided by a negative gives me a positive, so I have +3. Now, if I do 0 times -3, 0 times anything gives me 0. And we don't have +0 or -0. 0 is neither positive nor negative, so our answer is just plain old 0. And if I look at -10 divided by 0, remember what we talked about at the beginning, whenever we divide by 0, that's when we say our answer is undefined.